Okay, so in this video we'll be looking at expected value and variance of a function x. In previous videos we worked out problems of expected values and variance using these three rules to find two unknowns. And in this video we'll be looking at further rules, these rules here. And what's interesting about these is maybe for a mark in a question you'll be given the value of e to the x, and they'll be like, okay, now you've got the value of e to the x, work out the value of e, open bracket, ax add b, close bracket. And then this will be the rule. So you'd simply do a times e to the x, add b, similar to coding in normal A-level maths. And these different rules apply. So just make a note of these rules and go through the textbook questions, obviously after you know how to apply them properly. And constant repetition, these rules will get kind of compound into your brain, and soon enough you'll be reciting them second nature. So if we move on to a few examples, it'll become a lot more clear. So a random variable x has the expected value of 4 and the variance of 3. So e to the 3x, if we look at our rule, a is 3, so 3 e to the x. If you notice there's no add b on this question, so add b will be 0, equals 3 e to the x we've been given as 4, so this is equal to 12. For b, e to the x minus 2 is equal to, we notice a here is 1 e to the x, and b is minus 2, equals 4 minus 2, which is 2. For part C, we've got a variance question now. It's the variance of 3x. If you notice here, the b value does not affect the variance, because if we've got a set of data and we're adding on, say, 3 to every number, the spread of the data does not change. Okay, so this the a value is 3, so 3 squared times the variance is equal to 9 times 3, which is 27. If we look up d, if you notice, a is 1 squared times the variance is 1 times 3, which is just 3. Now, this one's interesting because we're not given a table of probabilities and variables, and so we have to use a rule that we learned in previous videos, which is that the variance of x is equal to the expected value squared minus the total expected value squared. So we've been given the variance, which is 3, which is equal to e to the x squared minus 16. So 3 add 16 is equal to e to the x squared. So e x squared is equal to 19. And this is how we solve a problem like this. So this example is interesting, and I've drawn out the probability table. We're using this rule. So if we're ever given a value of x and they kind of want us to transform it into another function, that's all we do. We calculate the kind of new value after being substituted into the function, and then we just do the normal procedure to calculate the expected value. So in my calculator, to get these values here, make sure you're in degrees, and you would do sine 0, sine 30, sine 60, and sine 90. And then it's just basic procedure for expected values. So find e to the sine x. So this is sine x. Okay. And this is equal to 0, 0.4. Add 1/2, 0.2. Add root 3 over 2, 0.1. Add 0.3 is equal to, now if we just plug this into our calculator, it's a bit of a nasty equation. And we get 8 plus root 3 over 20, or 0.4866. Okay, so for the last question, very similar to question 1. And so if you'd like to follow these 2 rules to kind of work out the solutions, and then you can come back to the video and we'll go through the answers. Okay, so we're going through the answers. If e to the x is equal to 1 and the variance is equal to 2, e to the 8x would be 8 times e to the x, which is equal to 8 times 1, which is just 8. For b, e to the x add 3, the a value is 1, so 1 times e to the x add 3 equals 1 times 1 add 3, which is 4. For part C, variance of x add 3. Again, the a value is the only value that affects the variance, and the b value doesn't, but the a value is 1, and so it's simply just the variance, which is 2. In this case, the a value is not 1, so we have to do the a value squared times the variance, which is equal to 9 times 2, which is equal to 18. For part E, variance 1 minus 2x is equal to, the a value here is minus 2. So minus 2 squared times variance of x is equal to 4 times 2, which is 8. Now this is interesting because, again, as you can see, a negative value here still has a positive variance. Okay, so F, you need to work out e to the x squared using the e to the x squared rule. So this will equal, let's just do our variance rule, is equal to e to the x squared minus e to the x all squared. Therefore the variance of x add e to the x all squared is equal to e to the x squared. And so the variance of x given in the question is 2. So 2 plus e to the x, which is 1, I believe. Let's just check that. E to the x is 1, is equal to e to the x squared, which is just equal to 2 add 1, which is 3. And that's how you'd solve for expected values. And I think this is the last video in the expected values for discrete functions. And so the next video we'll be looking at Poisson distributions.